Hi everyone, I am Yogita studying in Sri Venkateshwara College of Engineering. Today I am going to talk about embedded system hardware. Today's topics are what is an embedded system hardware, ARM bus technology, AMBA bus protocol. Now let us talk about what is an embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded systems may also function within a larger system. Here are some of the examples of ARM-based products. The first one is the Lego Mindstorm Robot ARM7. The second one is the GP32 game console ARM9. And the last one is the Apple iPhone ARM11. Here are some more products. iPod ARM7 TDMI, Juicebox low-cost multimedia player ARM7 TDMI. Now let us go to our main topic, which is the embedded system hardware. Embedded systems are designed to control many different devices, from small sensors found on a production line to the real-time control systems used in a NASA space probe. All these devices use a combination of software and hardware components. Each component is designed to provide higher efficiency and is designed for future extension and expansion. Here is an example of an ARM-based embedded device, which is a microcontroller. In this figure, the boxes represent the feature or a function and the lines represent the buses connecting the devices. Here, the ARM processor is connected to the interrupt controller and the AHB arbiter. Here, AHB is nothing but Advanced High Performance Bus Arbiter. The real-time clock and serial UARTs are used. Memory controller is used because as per the requirement, the memory is used either ROM, SRAM, flash ROM or DRAM. AHB external bridge is used for connecting with external bus. AHB APB bridge is used. AHB is nothing but Advanced High Performance Bus Arbiter. APB is nothing but Advanced Peripheral Bus. Here controllers and peripherals are used. Each box represents feature or a function. The lines connecting the boxes are the buses carrying data. We can separate the device into four main hardware components, which are ARM processor, controllers, peripherals, bus. Now let us talk about ARM processor. The ARM processor controls the embedded device. An ARM processor comprises of a core, the execution engine that processes instructions and manipulates data, plus the surrounding components that interface it with the bus, include memory management and caches. The second one is the controllers. Controllers help coordinate important functional blocks of the system. Two commonly found controllers are interrupt controller, memory controller. Next one is the peripherals. Peripherals provide input-output capability external to the chip. It includes serial input-output, parallel input-output, timers, counters and clock circuits. And the last one is the bus. Bus supports communication between different parts of the device. Controllers. Controllers are specialized peripherals that implement higher levels of functionality within an embedded system. Two important types of controllers are memory controllers and interrupt controllers. Memory controllers. Memory controllers connect different types of memory to the processor bus. On power up, a memory controller is configured in hardware to allow certain memory devices to be active. These memory devices allow the initialization code to be executed. Some memory devices must be set up by software. For example, when using DRAM, you first have to set up the memory timings and refresh rate before it can be accessed. Interrupt controllers. When a peripheral or a device requests attention, it raises an interrupt to the processor. An interrupt controller provides a programmable governing policy that allows software to determine which peripheral or device can interrupt the processor at any specific time by setting the appropriate bits in the interrupt controller registers. There are two types of interrupt controllers available for the ARM processor: the standard interrupt controller and the vector interrupt controller, which is known as VIC. The standard interrupt controller sends an interrupt signal to the processor core when an external device requests servicing. It can be programmed to ignore or mask an individual device or set of devices. The vectored interrupt control is more powerful than the standard interrupt control because it prioritizes interrupts. The next topic is the ARM bus technology. Embedded devices uses an on-chip bus that is internal to the chip and that allows different peripheral devices to be interconnected within an ARM core. There are two different classes of devices attached to the ARM on-chip bus. The first one is the bus master and the bus slave. Bus master. A logical device capable of initiating a data transfer with another device across the same bus. The ARM processor core is the bus master, bus slave. Logical devices capable only of responding to a transfer request from a bus master device. All peripherals are bus slaves. On-chip ARM has two architecture levels, physical level, protocol level. Physical level covers the electrical characteristics and bus width, 16, 32 or 64 bits. Protocol level covers the logical rules that govern the communication between the processor and the peripheral. Advanced Microcontroller Bus Architecture AMBA Bus Protocol, which is also called as AMBA. It was introduced in 1996 and widely adopted as the on-chip bus architecture used for ARM processors. The first AMBA buses introduced were the ARM System Bus ASB and ARM Peripheral Bus APB. Later, ARM introduced another bus design called ARM High Performance Bus AHB. Using AMBA, peripheral designers can reuse the same interface design on multiple projects. A peripheral can simply be bolted on the on-chip bus without having to redesign an interface for each different processor architecture. AHB provides higher data throughput than ASB. Because AHB is based on centralized multiplex bus scheme, ASB bidirectional bus design. ARM has introduced two variations on the AHB bus, multi-layer AHB, AHB Lite. The original AHB was allowing a single bus master to be active on the bus at any time, but the multi-layer AHB bus allows multiple devices. AHB Lite is a subset for the AHB bus and is limited to a single bus master. AHB Lite was developed for designs that do not require the full features of the standard AHB bus. Memory. An embedded system requires some form of memory to store and execute the code. The memory should be fast, large and inexpensive. Unfortunately, it is impossible to meet all the three requirements, so the common solution is to have the memory hierarchy. Thank you.